Today we're going to work on some basic 3D drawing creations. We're going to show you how to create some holes. We'll also show you how to create some features from multiple 3D solid creation, some basics in that way. As usual, we're going to go ahead and get started with the units command. Make sure that our units are set up properly. Decimal to decimal place is good. We're going to check our polar and object snap settings. So object snaps look like they're set up here. Perpendicular, intersection, polar tracking, 5 degrees. That looks good. And lastly, I've set up some layers. 3D layer 1, 2, 3, and a dimension layer. Made each one a different color. Didn't worry about line types or line weights for this particular drawing environment because it is a 3D model. So creating the 3D solid environment requires us to actually extrude or revolve a shape, and what is entailed with that is we need a polyline or a closed entity like a circle, an ellipse, a polygon, a rectangle to draw the basics. So I'm going to go ahead and start with the line command, and we're going to create a polyline or a region, both will work, to extrude for our base shape. So I'm going to go ahead and fire this off. We'll make this about 4.5 inches long. We'll do this at about a 45-degree angle, and we'll make this 3 inches. We'll come up 1 more inch. We'll come across and we'll come across and we'll make it straight across, and we'll make a right angle intersection, and we'll bring it back down. So basically a really basic shape for us to use. Now the key is that I can't extrude an object that has individual objects. So I'm going to use the boundary tool, which is found under the hatch. So we'll use the boundary tool to create the actual polyline. Now I can create a polyline or a region. What's the difference? The region is a two-dimensional solid, where a polyline is an exterior, basically linking the exterior shape together. In both cases, it requires us to ensure that all the corners have connections. And the concept is, when I pick a point inside, it's going to send little feelers out to find the edges of the entities, ensure that the entities touch and have endpoint connections. And when I right mouse click, a polyline will be created. Now the difference is that this is now a solid object. But here's also the difference. That solid object also has the original object under it. So all I did was move the solid object over. So you can see what happens is that it creates a new object on top of the original. Now theoretically, if I'm going to extrude it, I don't need the original object. So I could create 2 different layers, one for the original object shapes and turn it off. I can erase the original object shape since I've got the polyline created here. Or I can leave them both on top of each other. That will work also. So we're going to go ahead and begin the first step of the 3D creation, which is extruding this into a solid object. Now, the drafting and annotation tab does not have any 3D modeling capability, so I need to flip over to the 3D modeling ribbon system, and that brings up our coordinated efforts for developing the 3D models. In this case, we're going to be doing an extrusion of our object. Now there's also pre-made objects that you can use: boxes, cylinders, cones, spheres. So within the 3D modeling environment, I can have core components created. I can extrude loft, and a loft is basically taking two differing shapes and saying between the 2 differing shapes, or the 3 differing shapes as the little pop-up shows, I can make a smooth contour. I can revolve objects, and then I can sweep, which is basically like making a pipe or an electrical cord. You would want to sweep it. You'd make a path of the electrical cord, make a small diameter for the chord itself, and it would follow that two-dimensional path that you've created, or three-dimensional path that you've created. So I'm going to go ahead and extrude the object. So I selected extrude, select the object, right mouse click. It's going to ask me for how much of an extrusion do I want. Now I can pick a point and it'll pick the distance that's being displayed in the box. In this case, I'm going to make this 4.0 inches of an extrusion. Wow! You just created your first 3D solid. Doesn't look very 3D, does it? To make it look 3D, we need to pop up over into the draw box area, and we'll select the house. And you'll see that our object is actually three-dimensional, but it's wireframe. Okay, even though it's solid, it looks like a wireframe Tinker Toy set, or for working with the 21st century, the Connects style object, or erector sets if you really want to get into the old school shape of a wireframe environment. Now, realistically, if we want to see what it looks like as a solid, I have to change it from a two-dimensional wireframe shading to either a shaded or a conceptual. Realistic will be very realistic regarding the lighting, but I'm just going to do a quick shaded model, and you can see that the model is three-dimensional, and I'm just using the view cube here to spin it around, and the home will always bring us back to the home view. Now I'm going to do two things to this particular cube. I'm going to take a section out of the cube here, which is going to produce an angled surface, and then I'm also going to create a hole through the object which has a countersink associated with it. So I'm going to do two object editing capabilities. Alright, so I'm going to go ahead and we can keep it conceptually shaded, and the idea behind conceptual is that notice that I have different colors on different surfaces. So it makes it a little bit easier to see what surfaces that I'm working with. I'm always looking at the right side view as a purple, the salmon color is the left side, and the top is orange. So this is a good time to talk about the X, Y, and Z coordinate system, and it's called the user coordinate system when we work in 3D. And we have to place this coordinate system on the object for us to create shapes. So in this case, what's going to happen is I'm going to create the X-axis along the bottom part of the purple surface, the Y-axis along the vertical part of the purple surface, and the Z-axis will flow naturally. And it'll flow naturally based on the right-hand rule of your thumb, index finger, and middle finger pointed at 90 degrees to the Y-axis. It'll make sense here in just a second. We're going to do the three-point selection of the user coordinate system, and what this does is this has us select 3 points on the object. So I'm going to pick the lower corner as my origin, or 0, 0. The positive x-axis is going to go along the bottom, and the positive y-axis goes along the vertical. Now if you think about it, if your thumb, your right-hand thumb, is the x-axis, so if you point it like the direction in the screen, and the y-axis is your index finger, that's vertical, so you can rotate your wrist and manipulate your arm so it's similar to what's on the screen. When you point the middle finger out 90 degrees to the index finger, you get the z-axis direction. That's the positive z direction. It's called the right-hand rule. Can't do it with the left hand. Really mess it up. It actually does it opposite if you do it with the left hand. You can also see that the green, red, and blue axes is on the screen. Well, the green is Y, the red is X, and the blue is Z. And the longer the aspect of the length, that's the positive direction. So you can see how the positive direction is inferred by the icon of the user coordinate system. So what I'm going to do here is I need to create another object. And this object I'm going to subtract from this side. I'm going to cut off a shape. So I'm going to go ahead and go to my top view. Okay, and I'm going to draw it, and there you can see the X and Y, and the Z is pointing towards us. So I'm going to go ahead and draw a shape. Well, there's no drawing tools. Well, there are a few drawing tools here that we can use. We can use the Polyline, we can use the line command. So the basic draw tools are still here, but they're not as outsourced as the original ones. So let's go ahead and draw our object. And in this case, we're going to draw a cutting surface. So we're going to draw a cutting surface that is horizontally 2.5 inches, vertically 2.5 inches, and we're going to connect it as a triangle. Now, could I have done that in a polyline? You bet. So if I were to pick the Polyline command, and I'm going to draw the same object just above it with a polyline, we'll show you the difference. I'll pick a starting point, point and shoot, 2.5, vertical, 2.5, and I'll connect the end and right mouse click and choose enter. They look identical. Absolutely no difference between the two, except that one is made up of individual objects and the other one is a solid entity. So using the polyline to create your shape, probably very advantageous. I'm going to go ahead and erase the individual object. So let's go back to the home view and let's see what happened here. So we've created an object up here, and we're going to go ahead and extrude this. Now, we did an extrusion of 4 inches, so we're going to extrude this object by 2 inches. Now, there is the press-pull capability, which is one of the interesting features, and I can select my polyline, and I can press or pull the direction that I would like it to go. And for our creation, it makes no difference whether I press it or pull it, but it's kind of a cool way to actually extrude it as opposed to just doing the extrude command. We're going to go ahead and type in 2.0 inches and create the object. What I'm going to need to do next is take this object and move it in position, because I'm going to have to subtract this shape from this surface. So I'm going to use the move command, select my shape that I need to move, which is this object here, right mouse click. I'm going to pick the midpoint on the corner. I'm going to pick the midpoint on my block. Even though it didn't look like it was going to work properly, you can see that it actually did work properly. It centered it because it was a 4-inch extrusion that we did for the object, and so it's set up properly. So now we need to do the subtract command. And right here under solids editing are where some of the feature capabilities are that you can explore. And the 3 that are in a stack right here include unionization, subtraction, and intersection between the object shapes. So I'm going to choose subtraction. When you subtract objects, it's going to ask you to select the original object, or the object you want to keep first. So I'm going to select my keeping object first, which is the big shape. I right mouse click and select the object that I need to subtract, which is the smaller object, which is embedded. And I just selected the same object twice. There we go. So you have to be careful what you pick. And I held the shift key down and reselected to deselect. So holding the shift key down and selecting with your mouse button will deselect an errant pick. So I'm selecting that object as the object to subtract, and I right mouse click. Alright, surfaces cannot be subtracted from the solids or regions. Oh, so it created a surface and it didn't create a solid with the press pull. That caused a problem. So let's go ahead and undo a couple of steps. So even though I made the object with the press pull, I really do need to use the extrude or the poly solid. 3D like wall solid, not good. We're going to create a 3D solid. And the press pull only creates solid faces. So I actually need to create a solid object. and type in 2 inches. There we go. Should have had the clue when it surfaced it with the mesh. That was a clue that it was a mesh solid. So I had to undo it back to the original shape, and now we'll do the move command again. Right mouse click, midpoint to midpoint. Now we can use the subtract tool, selecting our original object shape, right mouse clicking, selecting the object to subtract. Uh-oh, another mispick. There we go. There's the object to subtract. Again, mispicks, shift, reselect. And I right mouse click and it subtracts that surface. So I can create really complex surface shapes and designs with it. But what about holes? How can I create a hole? Especially a hole with a countersink or a counter bore. Well, I'm going to do a quick countersink or a counter bore. We'll make a decision here in a second. Design. And so I need to make sure that I'm looking again, not from the top, but from the side of the object. And I've got that with the X and the Y. I'm looking at the side of the object as my current surface of work, because the X and Y denotes your current surface. Okay, we need to create a shape. In this case, it's going to be a counter bore hole that we're going to put through our object. And no matter what the shape happens to be, we're going to go ahead and get it started with a polyline. So again, I have to create a polyline shape, and I want the polyline shape to be along the end or end facing. Since I'm going to be drilling the hole straight through the object, I can't draw it from the top. I need to draw it from the side, so I need to make sure that the X and Y is on the side of the object. I'm going to go ahead and flip it around and tell it to be on the side of the object here. I'm going to choose the Polyline command, and in this case I'm going to create the polyline, and we're going to start at the bottom of the, in this case, hole. So I'm going to go ahead and make the hole 0.25 straight down, but we're going to make it 6 inches long. We're going to kick out the counter bore another 1/4 inch, and the, whoops, that was a bad angle. I want to make sure that we're straight up and down, 0.25, and then I want to go 0.375 vertical, and then I'll come back across and connect back to the original location. So that way, let me go ahead and zoom up on this. I want to connect to the original location straight across. And let's pan this over real quick and magnify. And theoretically, it's going to be a 0.50 up and then a connection across. So what I've done here is I've created basically half of the shape, and I need to revolve that. And so to revolve it, I'll use the revolve tool, and this is a counter bore, so I'm going to select the object to revolve. And then it's going to want to know what the axis point of revolution is, and I'm going to use the inside here as the axis points of revolution, and we're going to revolve at 360 degrees. So in essence, what I just did was I just created a representation of a bolt. If it was a countersink, I'd just draw an angle on the end as opposed to the countersunk component. So again, now I've got to figure out where it's going to be placed. So as you can see, we now have a representation of the bolt. And if it was a countersink, I would just have an angled surface up here as opposed to a square countersunk. Now I've got to locate it on my object. And the easiest way to do that is to put the user coordinate system back on the top surface and draw a construction line to the center of where that needs to be, and then move the bolt to that location. So to move the UCS again, we're going to use the 3-point. Now I could also use the face tool. There's a UCS face that allows us to work with objects. And there's quite a few different options. I can do it based on the view, but I like 3-point because I get to define the exact positions. It allows me to provide a little bit better control. So I'm going to pick the top corner here, positive X, and then positive Y. And you can see that the X and Y and Z now lay down. And what I'm going to do is I'm going to draw a construction line. As you can see, the representation of the bolt is pretty standard. It looks like it looks like a bolt. It actually represents the whole component that we're going to be removing. If it was a countersunk, I'd have an angle up at the top. To actually position it, I'm going to need to draw a construction line on the top surface. What that requires me to do is put the UCS on the object. I again like using the 3-point because the 3-point provides me control. And so I'll pick the top corner, positive X, and again, using that to help out for position purposes, and using endpoints makes it so much easier. Now I need to draw a construction line to the position of where I'd like to place this, and I'm just going to go ahead and draw a regular line command. I'm going to let's go ahead and change the layer to 3D layer 2. And I'm going to draw a construction line across. So I'm going to just draw a line from here and perpendicular. If it had to be an exact distance in, I would have actually point and shoot. If I had needed to draw from a corner, I would draw from a corner and then point and shoot. Let's do that. Let's trade this up just a little bit. So let's say, for example, I need to move it a ½ inch in from this corner here. So we're going to draw a line, point and shoot 0.50, and then I'm going to draw it across perpendicular. And there's our line. So I could actually connect in. And there's actually a line here which will turn off because it's on layer 2. So positioning the hole, I'll use the move command again. We're going to select the object. We're going to position it based on the center of the top to the midpoint on the line. Now again, if it had to be an inch over, then I would have point and shot just an inch over from that edge. But I knew I was going to put it in the center, so we'll locate it there. It's okay that it goes out the bottom. Matter of fact, that's beneficial. We want to make sure that the bolt was long enough, or the hole was long enough to go all the way through the part. Alright, again, a subtraction command. So we're going to pick solid subtract, pick our keeping object, which is the original shape, right mouse click, and this time I'm going to go ahead and pick the part that I can see down here at the bottom. I'm not going to try to pick it in a location that I might pick one of 3 lines. I'll make sure that I pick the easy one, which is down here. And right mouse click, and as you can see, we subtracted it out and we now have a hole through the object. Turning off the green layer number 2, I'll turn off the current layer, I'll flip it back to green layer 3, but you can now see that with the hole, with the ability to rotate it, really easy way to create a fairly complex shape. The key thing to remember is the user coordinate system. It's preferred to draw in X and Y. Always draw on the surface that you need to work on, or on the surface that you need to create the shape based on. Have a great day.